Hello, everybody, and thank you for joining today's RULA webinar on calibration called Everything Everywhere One by One. I'm here with you. My name is Elena Malitz, and I will be moderating today's webinar. Thank you very much for joining. Thank you for your interest. And first and foremost, I would like to ask you to type a plus or pretty much any sign in your questions section on your webinar operation tool, if you could, because we need to check that you see the presentation and that you can hear as well. You can also use the same box to ask questions at any point of the webinar. We will try either to answer as we go, or if it's not quite related to the content of the webinar, then we will just wait for the questions and answer session at the end. And we're going to wait for maybe another minute or two for more attendees to join. Okay, very well, thank you. I understand that we are heard and viewed very well. So slowly we will start proceeding to the beginning of our webinar. And before we go on, I would also like to introduce the second speaker today, my colleague, Alina Zharikova. She will be the key speaker and will cover the details of our software for calibration, while I will just give you the presentation of the beginning and we'll just moderate the discussion if there is.
Hello, everyone.
And joining us today, we also hear the Chief Software Developer, Ilya Sokolovs, and he's here to answer your trickiest questions and anything that concerns you about our software or hardware for that matter. Whether it is related to calibration or not, please don't hesitate to let us know and we'll try and handle all the questions. Okay, and while more people are joining, I will start with a brief introduction to RULA technologies. If you're still new to RULA, let me just give you an overview. We're based in Riga, Latvia. We are a manufacturer of vibration control, data acquisition, shock loggers, calibration, and related software. And here on the screen, you can see what we consider our key advantages. So we provide tailor-made solutions, which means that we listen very closely to the feedback of our customers, and we try to constantly improve. The software that you get with our devices is supported for life. So you get free software updates. You don't have to invest more than once. We provide lifetime compatibility with your devices, and we care very much about installation and training. So we make sure there is free online education and that our support is on 24/7. Yeah, and it's also worth mentioning that we cater for automotive, aerospace, research, military, and power and energy, and another a range of industries that may need our solutions. Okay, I think we can move on to the main part, and let me just give you a brief introduction to what we'll be looking at. We will go through theoretical basics, not too in detail, just the main definitions to introduce the subject. We'll talk about what calibration is and the necessary calibration intervals. What is more important, I guess, we will talk a little bit about the equipment you need for calibration procedures. As today we're talking about calibration of accelerometers briefly, then we'll talk about calibration of microphones. These are the two modules that are more developed, that are not new, and we feel quite confident in this fields, but we're developing further, and our newest additions are shock sensor calibrations. We'll be talking about that too, and the oncoming release of sound level meter calibration will be covered in most detail for today. And the main part of this webinar lecture will be the software overview. It's important that you see how comprehensive and easy RULA software is, and that you will be able to calibrate the devices in your lab in no time. And we, as always, leave some time at the end to go through questions and answer session. Yeah, that is pretty much it. But as I said, you can ask at any point of the discussion. Okay, without further ado, let's move on to the definition of calibration. Calibration is usually defined as the procedure of comparing of measurements of the device under test to some reference standard, to a reference device. And what we offer at RULA is a suite or a set of modules of software for calibration purposes. We do calibrate accelerometers, we calibrate shock sensors, microphones, and sound level meters. So it's already implemented and will be released in the up and coming release before the end of the year. So we thought it's worth it to start and give you a sneak peek on this module. And a really crucial point is standards for calibration. So if you want to equip a lab and you want to deliver service in calibration, of course you'd be interested in the standard our software complies with, and here they are. You can see them on the screen. Standards for sensor calibration, for shock sensor calibration, for microphones, and sound level meters. We're often asked how frequently does one need to calibrate their accelerometer or their device, and it's not a trivial question because, as you know, annual calibration is a standard, is considered the gold standard. But however, if you're working in some extreme environments like heat or cold or high pressure, or there are some peculiarities to your process, you may want to calibrate with every 6 months, yeah, or even more often, just to make sure that you catch the drift of accuracy before it impacts your data and is in the way. So unless you have a specific standard in your enterprise, you want to observe your process, and you just want to make sure the data does not drift. So maybe 6 months is even better than annually. So another thing that we wanted to feature is the controller. So we're starting here to explain what equipment you're going to need for calibration of the listed type of devices. And we at RULA think that controller is the main player, that controller is the key, because it is the controller that is going to perform all the calculations. And we manufacture and provide a range of vibration controllers that are going to cover all the needs for a calibration lab. And you can see our range here. For now, it's RLC21, RLC21M with 8 channels, and RLC25, the modular system. You can see that the main difference is in the frequency range that you're going to be focusing in case of calibration. Now let's cover very briefly the equipment you're going to need for sensor or accelerometer calibration. You can see the controller that I've just mentioned down there, and on top there is a PC with a pre-installed TestUp software calibration module. Then we have, excuse me, then we have a shaker. Could be a specific model shaker or a small shaker for calibration. There's a range of brands that you can use. And then in the center of the picture, you can see our RULA 200. It's a power amplifier with 200 VA power output, ideal for calibration purposes. And then at the background, you can see a long stroke shaker. It's a relatively rare device, which you're only going to need if you're going to cover the lowest range from DC, from 0 to 2 or 3 hertz. In this situation, you're going to need not 1, but probably 2 shakers to cover the whole range for calibration. What is important to say is that we are ready to provide the whole set. So even though we produce the controller, the amplifier, and the software, you can order the whole set to equip your calibration lab from RULA, and we will deliver. Now for shock sensor calibration, essentially you're going to need the controller and you will need a shock machine. There is a whole range of brands and kinds, so we're just featuring like one way it could look. And of course, you're going to need a reference sensor and your sensor under check. Now to microphone calibration, and here you can see a more complex picture. And this is an ideal situation standard. And in this situation, sensitivity at the base frequency is defined with a calibrator, and then the frequency response is defined with the actuator. So you're going to need a controller, a preamplifier, your reference microphone, your microphone under check, a calibrator to measure sensitivity. Then you're going to need a controller, an actuator's amplifier, an actuator, and microphone under check to measure the frequency response. So it's a slightly more complicated scheme, but we are ready to guide you through the connection and the necessary hardware to collect the complete system. Yeah, there is another way you can perform calibration of microphone, and it's a slightly different set. So what you could do, you could use an acoustic coupler in order to define the sensitivity at the base frequency. And then at the next step, you can measure the frequency response with the actuator. Now, about the equipment that you're going to need for sound level meters. Here is a slightly more complicated situation. You don't see any scheme here because there's a range of such devices. And with every kind of device, you're going to have to refer to the related standard. And in this standard, there will be steps or methods described. And depending on these methods, which are, by the way, all implemented in our software, the set is going to be different. So there are about 4 possible sets that you could gather in hardware configurations that you could have to collect for performing the calibration of sound level meters. So we decided not to bore you with like 4 variations, and just we're going to show one because we have a sound level in our lab here at hand. But then if you're interested and if you want to dive deeper into the calibration of sound level meters, we'll be ready to give you an article from our specialist and like further guidance on what you're going to do with your specific sound level meter type. Now, this was basically the introduction to the equipment that we have, and now we're going to dive into the software, the TestUp software, and we'll go through each kind of calibration. It will not be very detailed for accelerometer calibration and shock sensor calibration because we have done webinars on that before, even though we will show it quite fast, quite briefly, and we will devote more time to our newer sound level meter calibration software. And I'm passing the microphone to Alina.
Thank you, Alina, for telling the theoretical basics of calibration. And now let's open TestUp. And here we will go through the all available options, software modules for calibration. So here you can see the icons, sensor calibration, for microphone calibration, shock sensor calibration, and sound level meter calibration. And we will begin with the sensor calibration module. It is considered to be the most requested option for calibration. As it was already said, the procedure complies with the ISO 1606321 standard. So let's open it. We click on Test Settings button. And here we can see the sensor parameters. Where I would like to pay your attention is to Open Sensor Database. And here you have the database of available manufacturers and sensor models. The database means that we have already put all of the parameters of sensors in accordance with their passports in our software, so you don't need to enter anything. But in case you don't have the sensor you need for calibration procedure, you just can simply click on the Add button and add the parameters you need for your sensor in accordance with the passport. In the Measurement Parameters tab, you can enter calibration parameters and select the measurement modes. The following methods of calibration are available in TestUp, so it is sign, random, manual, and substitution. And if the sensor under calibration is mounted directly on the reference sensor, such a procedure is called a back-to-back calibration. And just a few words to highlight the difference between these methods. Usually in a back-to-back calibration, a sine wave is used to excite both sensors. And when the sine wave is being generated on the shaker, the output signals of the reference sensor and sensor under calibration are measured. The procedure takes about 10 minutes. So let's pretend that we have filled in all the parameters and we can save the settings for calibration in sine measurement mode. So let's press OK. And here I would like to pay your attention to the manual mode in the bottom. It is applied to generate a certain frequency at a certain level. Now let's open again Test Settings. Well, in addition to sine wave excitation, we provide calibration with the random signal excitation, and it is presented by FFT H1 and FFT HV measurement modules. And in this case, the shaker is excited with a random signal, which contains all the frequencies in the sensor frequency range. And if a random signal is used, sensitivities on all the frequencies are measured simultaneously. And this way of calibration reduces the calibration time to 3 or 4 minutes. For more accurate results in sine and random in the low frequency range, so it is from 0.1 up to 2-3 Hertz, a laser vibrometer is applied, and it can be found in the Equipment tab. So here you can put a tick to use a laser vibrometer. Although back-to-back calibration is widely applied, it can be inaccurate if the sensor under calibration is bigger or heavier than the reference sensor. And to avoid such an error, in TestUp software, we implemented the procedure of calibration by substitution. And this feature can be chosen in the measurement parameters, so you can just put a tick to use substitution method. And this method allows, of course, for maximum accuracy, but unfortunately it takes more time. After any calibration, TestUp automatically creates a report, which includes measurement results in the form of tables and graphs, detailed information about the reference sensor, calibration date and place. And I would like to open the presentation to show you the way it looks like. So as I said, you can find in the report the model of the sensor, the manufacturer, all the parameters you need, you got after the calibration procedure. Now let's move on. Yeah, also what I wanted to add is that in detail we discussed all of these methods in the webinar devoted to the sensors calibration, and the link to this webinar we will send to you after the end of this event. Good, so now let's move on to the shock sensors calibration. We need to switch the module we have. And the procedure of shock sensor calibration is applied when the amplitude characteristics of the sensor are to be determined. And as Alina said, ISO 1606322 is the main standard for the shock calibration procedure. The process of shock sensor calibration can be divided into two parts. First, we need to perform a series of high amplitude shocks. And second, we need to compare the results with the reference accelerometer data. So let's look at the sensor parameters tab. Here we can choose the sensor model from the sensor database. We need to enter its serial number to specify its type and sensitivity. And what is mostly important here is to add shock levels. So for example, in our webinar devoted to shock sensor calibration, we added 4 shock levels. There were 20G, 50G, 70G, and 100G. So they can be added this way. Next, you need to add measurements parameters and the number of averaging, which indicates the number of shocks you need to apply for each level. And the number of averaging can be found in the measurement parameters tab. So it is here on the right side. So for example, we put here 5 shocks we need to do. And in the channel settings tab, you need also to add reference accelerometer parameters and define the channels for the reference sensor and the sensor under check. And as it was for the sensor calibration, you also need to fill in the reports settings, and after the calibration procedure, you will get the report. Good. Now let's go to the procedure of calibration for microphones. Let's open it. Takes a little time. So while we're waiting, a few words about microphone calibration. So the basic procedure of how to calibrate microphones is described in the standard IEC 61094. And this standard describes 2 methods of measurement, by sound pressure and by free field. Both of them are available in TestUp. Now let's have a closer look at the software interface. And first, I would like to pay your attention to the bottom of the window. Here you can choose use an anechoic chamber if you need to perform a calibration by free field, or you can put a tick to use coupler for the base frequency, or to just use the coupler if you need to perform the calibration by sound pressure. Next, we are to look at the reference microphone parameters. So we have the base of references. So here you can choose the manufacturer you have of your microphone and the microphone type. You are to specify if IEP voltage is applied, the sensitivity of the microphone, the check date of the calibration, so on the date of the next check. And here I also wanted to pay your attention that the reference microphone FREF panel allows you to set the dependence of the microphone sensitivity from frequency. So you can see it on the left in this window. And in this table, you can fill the FRF. Next, you are to specify the parameters of the microphone and the check. So you are to enter here the serial number of microphone, its sensitivity, sensitivity deviation limit, channel, and so on. And after the calibration procedure is done, of course, you will get your report automatically. And finally, we would like to give you a sneak peek to the upcoming module of sound level meters calibration. Let's open it. Well, the main difficulty in calibration of the sound level meters is that every sound level meter has its own guide of calibration, including certain steps of this procedure. And the variety of sound level meters is so wide that it is hard to imagine that any software includes all of them. What we did, we tried to make the process of sound level meters calibration as user-friendly as possible and organized the interface in a special way. So we created a list of all steps of sound level meter calibration described in its standard IEC 61672-3, and I will show you these steps a little bit later. Just wanted to tell you about the advantage of this module. So the advantage of our module for sound level meters is that depending on the sound level meter you have, you can choose the steps you need to perform and configure the parameters in accordance with the sound level meter's passport. So now let's have a closer look to the module's capabilities while performing the calibration of the sound level meter that we have today. And I would like to open the presentation to tell you a few technical characteristics of the sound level meter we have. So it is Center 325. And it has electric condenser microphone. Its accuracy plus minus 1.5 decibel. The level ranges in which the sound level meter works. So the sound level meter has 3 level ranges: low, medium, and high. Frequency rating are A and C. Time ratings are fast and slow. The dynamic range of the sound level meter is 50 decibel, and the frequency range of the sound level meter is from 31.5 hertz up to 8 kilohertz. So now let's go back to the software, and we will create. So I will just want to create this sound level meter one more time with you. So Center 3251, we will do it this way. Okay. So in accordance with its parameters, we choose time and characteristics fast and slow, frequency corrections A and C. And now we add 3 ranges. So the low range starts from 32 and goes up to 80. Middle range from 50 up to 100. And the high range from 80 up to 130. After that, we need to enter the capsule. And here we will add Bruin Care type 4189. And next we open verification operation. So as I said, these verification steps were created in accordance with the standard for sound level meters calibration. And for this sound level meter, unfortunately, we can show you only one step. and it is indication at the calibration check frequency. So let's add it. So we need to click on the green plus. And by clicking on the button, you will see a window where you can enter the way how the procedure of calibration should be performed for the sound level meter under calibration. And in the window, you can see the instruction to perform this step of calibration in accordance with its description in the standard. This keeps the correct procedure always visible to the user, streamlining your workflow. And every time you click on this button, you can see the guidelines of what you need to do to perform the calibration procedure. And here we will set some of the parameters. So number of measurements is 3. Measurement error limit 0.7 decibel. Sound level in calibrator 94 decibel. So let's press OK. Now you can see that the first step was added to the procedure of calibration, and let's perform it. So we press apply and OK. We check that we put here the serial number, the capsule, the sound level meter module, of course, and now we can apply it and start our calibration procedure. So you can't see it at the moment, but what I'm doing is I put the microphone capsule of the device into the slot of the acoustic calibrator. So you can see the description of the procedure on your screen right now, and I am performing it in our lab. And we are starting to get the result. While we're getting the result, I would like to tell you about the basic measurement error of the sound pressure level. So it should not exceed plus minus 0.7, and it means that the maximum value possible should be 94.7 decibel, and the minimum possible value should be 93.3 decibel. So the first value that I got is 93.8. Now let's get the second value. Need a few seconds. So my second value is 93.9. Okay, so we can see the deviation from the calibrator. And the third value is 94. So based on the data we got, we can conclude that the sound level meter deviation from the calibrator doesn't exceed the sound level pressure level, and that our sound level meter was successfully calibrated. And also, although we have already performed calibration for the sound level meter we have today, we also would like to pay your attention to this step, electrical signal tests of frequency ratings. This step isn't applied to the sound level meter we have today, but it is very important to show it to you because it is one of the main steps in the calibration of sound level meters with a removable microphone. So let's open test settings and let's continue to work in the sound level meter we created. So we add another step. So as it was in the previous step, there is also the description of the step you need to perform in accordance with the standard of this procedure. The test procedure in this way, in this case, consists in applying an electrical signal from the output of the control system to the input of the sound level meter by passing its microphone. Measurements are made by scanning over the entire frequency range. And before performing the test, it is necessary to adapt the default measurement table by removing frequency ranges which are not spotted by the sound level meter. So this means that if you have the sound level meter with the frequency range from 1000 to 8000 hertz, for example, you don't need 16,000 hertz and 20,000 hertz, and you just can delete them this way. And in the report settings, you can add the name of the calibration technician, environmental parameters, save the test, and at the end of the procedure, you will get the report. Okay, so this was a sneak peek to the sound level meter calibration, and we hope that this module will be soon released.
Do we have any questions?
So let's check the questions section. So I think while our attendees thinking about the questions they may have, I will conclude our webinar. So as we discussed today, the regular procedures of calibration guarantee that your device works properly, it is safe and reliable. And at RULA, we offer a complex of modules for your needs of calibration, including sensors calibration, shock sensor calibration, microphone calibration, and even we have the upcoming module of sound level meters calibration. During our webinar, we walked you through all these modules for calibration. And as I said today, for sound level meters, we have created a special procedure which allows you to add different steps of calibration to perform calibration of a particular sound level meter in accordance with its datasheet. Well, if you're interested to get a calibration package for your needs, please contact us and we will cover all your questions and find the best solution for your needs. For a few minutes, we'll wait for questions. So unfortunately, we don't see any questions right now, but maybe these questions will come to you in a few hours later. And I would like to thank you for participation and for being with us. We hope that this session was pretty informative for you.
Yes, thank you very much for joining. And you will get a follow-up within, I think, a day or two. And if some questions come to you, please don't hesitate to let us know. We'll be glad to give you more information, to give you an online demo specifically for you, or a demo software to try and use it on your own base. And as always, we thank you for joining our events. Please stay tuned for the oncoming webinars. Thank you and have a great day.
Bye.